Alright, here's question 7. So for A, we're being asked about how far the center of mass is for the two stones. So first we need to find how far each stone goes. So for the first rock, it travels for whatever time you're given. In my case, it's 0.38 seconds, the same as 380 milliseconds. So then we use distance equals 1/2 AT squared to figure out how far it goes down. The reason why it's positive is because it says how far below. That's why we use positive. So that's how we find when the first rock how far it went, and then the second rock we do the exact same process, except we take the time here minus the time here as our time, and then use 1/2 AT squared to get the distance of the second rock. And then using the center of a mass equation, we take the distance the first rock went times by its mass, which is just mass, we'll call it. And then we take the distance the second rock went times by its mass. In my case, the second rock is 3 times the mass of the first, so it's 3 mass. And then divided by the total mass, which is mass plus 3 mass, or 4 mass. So then you do this, you multiply it and add, divide it by whatever amount of masses you got, and then your answer should be where the center of mass is. Relatively simple. And then for B, it's very, very similar, but instead of mass, you use speed. I mean, not mass, but instead of distance, you use speed. So to find speed, we just use acceleration times time. 9.8 times for rock 1, its speed is 9.8 times the time, which in my case is 0.38 seconds, or 380 milliseconds. For rock 2, it's 380 minus 170, which is 210 milliseconds, or 0.21 seconds, times by gravity, and that gets the speed of the second rock. And then I take the speed of the first rock, multiply it by its mass, which is just 1 mass. And for the second rock, it's just 3 mass. We don't know the actual mass, but we don't need to. And then we divide it by 4 mass, and that gets the speed of the center.